Welcome back. Again, we are coming to a more organized slide for the layers categorization related to the Association for Advanced Cost Engineers International categorization of the delay analysis method. We are now on the retrospective. As I mentioned, the prospective is only one method, which is the classical time impact analysis, but for an activity or as an event that has not yet started. In the retrospective, we have two big categorization called the observational or model. The observational or modeled are related to those activities or those methods based on the timing or not the timing is the first one, or based on or categorizes the layer number two categorizes the methods based on something called the basic method. So the basic method is either observational or model. Again, I'm not going to jump into further details, but however, we have to stop here because this is the major difference. Normally, when we were dealing with delay analysis and events and stuff like this, we come to realize that it's the proper way to represent the event with a fragment. Fragment is a small network that represents the event. We do it in a Gantt way, and we plug this Gantt way or this Gantt chart into the major Gantt chart, which is the schedule, and impact the relevant activities. In here, we have two basic methods, one called observational and the other called model. Basically, the observational methods do not recognize the fragments. We use the updates only. We monitor the critical paths, the change in critical paths using the major updates or using the major activity update, the major schedule update. The modeled is coming from the word model. You are modeling something. One of the model you are doing is the fragment, and you are implementing this fragment. So you are modeling or creating a new model in the program. So observation is what does not rely on fragment. Modeled is the one relies on fragment. So you have either the observational option. So if you go for observational, you will know that we are not using fragments. We are either using representation or simpler representation that does not require P6 in the first place or any scheduling tool in the first place, or we are using the update to represent the change in critical path without analyzing or without looking for a fragment that will be implemented or that will be plugged into the model of the schedule. It also determine the delays. I'm talking about the observational by trade, not by event. So I will analyze the updates and recognize that the electrical work trade is the work driving the major activity or driving the major the longest path or the critical path. Or by area, you will know that antelope area or floor number 3, floor number 4 is the one driving the activities itself, the expansion of the activity duration or extension of the activity duration or the late start or late finish will represent the impact that you will need to search for. It's a bit more complicated. However, in some cases, and I witnessed some of these cases, the employer requires an observational method to analyze any delay analysis. Why is that? This will, I don't like to say oblige, but it will give some kind of obligation to the contractor to structure the schedule properly and do a proper update on a proper time on an adequate timely basis. So I will be doing the update and I will be having the updates well recorded, and I will use officially submitted records to support my delay analysis in case of observational. In the case of models, in case of modeled methods, the model is just you are doing the fragment and you're plugging the fragment inside the schedule, and either you do it by adding the fragment or subtracting the fragment in the first place. Anyways, we will come to the layer 3, but anyways, modeled concerns or dictate doing some changes or adding some outside elements to your schedule. Observational does not. You may do some changes, you may do some modification inside the schedule, but you never bring a fragment or bring something from outside to your schedule. So this is layer number 2. So when we go to layer number 3 in the observation, so we don't use fragment, we go for either static logic or dynamic logic. Static logic dictates that you do a baseline, and then this baseline contains a certain sequence, certain structure, and you will keep this structure and sequence all across the project life cycle. How this can come? It can come in engineering projects. We use some fixed sequence to represent engineering projects. We can go for the linear projects. We are talking about sections that are not being changed from section to section, doing a railway section or a water line section or a sewer line section, something like this. This is tend to be static logic. Be aware that I'm not talking about delayed activities. Activities can delay, but the sequence will remain static. The dynamic is the normal one. You do the baseline and you start updating the program. You face challenges on site. You face challenges in the sequence. You might change the sequence. You might do things in the acceptable way of the out of sequence. I'm not going to dive into this because the out of sequence thing is a controversial thing inside something controversial, which is the delay analysis. But anyways, the dynamic logic is the most common one. We are doing a construction project. The contractor is the owner of the sequence, and the contractor can do whatever he wants, not to a limitless extent, but he can use the site circumstances to adjust the sequence, do a section before a section, do a floor before a floor, especially in fit out and MAP and roadway sections and interchanges and bridges. These things, or most of the construction projects I'm not going to say suffer, face or experience change in logic. So the baseline sequence will not remain static, which is the common case. In the static logic and the dynamic logic, we can go for layer number 4, and from which came 3.1, 3.2. 3 means we are coming from layer 3, and this is the first method under layer 3. 3.2 is we are coming from layer 3, the static logic, and this is the second method. 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9. These are the 9 major methods and main methods under the Association for Advancement of Cost Engineers. We call them the MIP, Method Implementation Protocol. So when we name the method we are using under the association, we say it's MIP 3.1, MIP 3.2. This is where the naming of methods based on the association's reference came from. 3 is layer 3, 1 up to 9 is what represents layer 4, which is that basic implementation. So we are in the specific method now, basic method, a specific method, the static logic, dynamic logic, and the basic implementation is 3.1, which we name the method after. In the model, we are using fragments. So these fragments can be added. So it's the classical way, doing a fragment and adding it, or you develop an entire new program in the way of but-for. But-for means that you will create an as-built schedule, and as-built schedule in the essence of extension of time is far different from updated schedule. So in the terms of project controls, they are the same, but in the essence of extension of time, baseline schedule is a kind of schedule. Updated schedule is another kind of schedule. As-built schedule is a third type of schedules. Anyways, either we add the fragment, so it's classical, or we go for subtracting. Subtracting means that we develop an as-built schedule in a retrospective mode representing the existing deterministic scope plus the variation or the event. Let's just go for an example. This is the first step. If we are doing excavation and there is soil replacement, and once we start excavating, we find out that we have a groundwater table that is not mentioned in the geotechnical. So an event came which fragments, it's not a correct English word, which is getting fragmented as finding groundwater, dewatering, and then clear an inspection, and then start the soil replacement. In the additive, I will do it like this. I will just create the inspection, or create, sorry, the fragment, and put it and see the impact. In the subtractive, I'm going to forget about the baseline. I'm going to forget about the update, and I'm going to establish a new schedule, contains the excavation with the actual duration, but with no actual P6, with no A percentage 100 in P6. But I will, for example, if the duration of the estimated duration is 10 days for excavation and it took 20 days, so I'm going to put an activity of 20 days, and then after this activity, the sequence will be that I find groundwater table milestone on the actual date, and then I've done dewatering for another 10 days, and I've done an inspection for 1 day, and then I start soil replacement for 30 days. This is my as-built schedule. The subtractive, I will go and dissolve the event. I will just imagine that this event is but for or has not happened. So I'm going to dissolve the event, and I will see what will happen to the time for completion. This is a simple way of representing the subtractive mode under the model. So observational, you have static or dynamic logic. Modeled, you have additive or subtractive. The basic implementation is the simplest way. The static logic, we have gross, so you will apply your method 3.1. It's no fragments. It's a static logic that the logic will not change from the baseline to the update. And I'm going to do it on the entire project, on the entire baseline, on the entire line, on the entire schedule. I'm not going to segment the schedule or slice the schedule. It's just one schedule baseline versus the schedule, the schedule actual or the as-built, and I will see where the delays come from, and I will go for substantiation and see or mention that this schedule, this delay came from 1, 2, 3, 4, 5, 6, which means I'm going to put the concrete line with 300 days, and I'm going to put the other as the baseline, and I'm going to put the as-built as another 400 days, and the difference, the 100 days, I'm going to say this happened because 1, 2, 3, 4, 5, 6, and that's it. This is my schedule, or this is my extension of time claim. And believe me or not, I have witnessed a lot of cases that use this to submit the schedule, to submit the extension of time claim. 3.2, 3.3, 3.4 are technically the same. You are doing the same steps. You are slicing and studying the impact or the events, the delays, not as fragment, but as change in critical path in segmentation. So window 1, window 2, window 3, window 4, window 5. The only difference is that 3.2 is compiled for activity or schedules that will never suffer any change in sequence. Examples like the engineering, the design, the linear. But 3.3 and 3.4, the as-is or split, the 3.3 are under dynamic logic. So we are going to segment the updates and monitor the change in critical path in updates that we know that the sequence of these updates are far different or different from the baseline. 3.3 is taking the updates or taking the updates as they are. 3.4 allows the analyst to do some modification. In 3.5, modified or reconstructed, they presume that you don't have in the first place any schedule or have short schedule or master schedule. So they allow the analyst to create the schedule based on the project record, create the baseline and the updates, or create the baseline and or the updates. And then once they have, or once the analyst have, once the analyst has all the information, the ASPILT, he creates the ASPILT, he creates the baseline and creates the updates. And once he has this in hand, he starts doing 3.3 or 3.4, 3.3 most probably. So 3.5 is not a method, it's just a 3.3 with an extra step of developing that schedule in the first place. And this happens when you don't have any schedule and you need to do a delay analysis for the sake of arbitrational case or dispute resolution case. In the additive, we have the single base, which is the impact as planned. We have one schedule and we put multiple fragments inside this schedule and monitor the dominant event, or monitor the dominant schedule event, or monitor the dominant delay event and the dominant critical path. The multiple base is the window analysis. We insert the fragments in steps. We can, in the subtractive, do the single simulation in the entire schedule. We create one big ASPILT and subtract the activities, or we go for multi-simulation and do it as separate ASPILTs and do it one by one. And I have to mention that 3.9 by the RP is the most theoretical method of implementation, and it faces a lot of challenges in terms of practical implementation. The layer 5 is just giving you an example, or giving you not an example, is giving you the allowance or giving you the option of using either fixed period or variable period. If you can do periods that are equal to each other, fixed, or you can vary, or you can do all periods, or you can do just segmentation, small segmentation. So it's just doing some detailed implementation of how you divide the windows inside these method implementation protocol, which is layer 4. Okay, so here in the last layer, we can see that we have a lot of common names. Just monitor something before we go to the next slide. Time impact analysis, time impact analysis, time impact analysis, time impact analysis. This is 4. Time impact analysis 5, time impact analysis 6, time impact analysis, time impact analysis, time impact analysis. We have 9 methods that can be called time impact analysis. That's why I normally have some conservativity on conservation on the clause, the famous clause included in some contracts stating that we are going to go for this using time impact analysis. Because if we go to a respectable reference like the RP, we can find that there are multiple methods that can be called time impact analysis. Method implementation protocol, as we mentioned, we have another reference called the SCL, Society for Construction Load Delay and Disruption Protocol. It categorizes the method by the concept of implementation. So we have as planned versus ASPILT, impact as planned, but for a collapsed ASPILT, time impact, and progress sustainability and statistical analysis, which is not an analysis. It's something that uses productivity to and something like the measured miles or the loss of productivity or loss of productivity to calculate the time impact or the delay. Actually, the most important is the next one, which correlates between both of them. So we have the as planned versus ASPILT. It can be represented as 3.1 and 3.2 and 3.3. You can use this one or this one, but 3.3 can be named windows as well. The time slice analysis, which are windows, it can be 3.3 and 3.5, and it can be 3.3, by the way. Time impact analysis, it's 3.6, and some people are using it for 3.7 as well. Time impact as planned, sorry, is the 3.6. Time impact analysis is 3.7. Collapse ASPILT is equal to 3.8 and 3.9. And longest path is C-text, which is, the text is mentioning what I mentioned in the previous slide, which is that we can use the loss of productivity to calculate it without even going to Primavera. By this, again, as a major adjustment or managing of expectations, I'm just giving you some in a nutshell what are the methods and how we categorize the method. This is a nutshell, again, not a detailed explanation of this one. If you want more information, you can go to page 12 of the RP. It represents, or it explains in detail, starting page 12 going on in the RP, what is the categorization system by the Association for Advanced Cost Engineers. Or you can read the SCL. The SCL is not a big document. It's something like 30 something or 40 pages document. This is the version I do have. So you can just go further and clarify. There is also, I'm going to just to come back again, there is this paper. I will share with you this paper. This paper is correlating between the association and the SCL by James Livingwood. I'm going to search for it and try to share it with you, from which I got this table. Okay, thank you very much. Once I finish, I will start after to record the videos of the 5 examples I promised you with. I promised you I'm going to do it in the previous lecture because I want just to focus. I found out when I went to the second lecture, I found out that the information included are it includes extensive information. It includes too much information. So I didn't want just to explain the whatever included in lecture number 2 and then start doing examples. So what I'm going to do is I'm going to record these examples in videos and share these videos with you within the coming days, weeks. Once I finish an example, I will share it with you. This is the first video. It will be followed by an example of MIP 3.3 in a roadway project that will follow in the next video, which is the example number 1. So the first video here is explaining how the method is just to set a common ground when I start explaining the methods, explaining the examples, since I'm going to use the RP2903. Thank you very much, and wait for the next video.